Right. So the first thing, and Chelsea was already doing this for me, thank you, sister. I said, interpret the slope of the best fit line in context. Yes, the slope of the line is 1.05. Yes, it is. Which means for every rise of 1.05, there is a run of 1. Yes, and that's an average. It's perfect. It's perfect. What does it mean? That's what I want to know right now. In other words, if you had to explain to you're out there working in your garden, and your next door neighbor who has never taken a math class in 20 years wants to know what all the hubbub is about in the news, and you explain this to them, and they go, dude, I hated math. What is this 1.05 crap you're spouting to me? You tell them in good English, what does the 1.05 mean? Please, Amber.
The amount of Americans that don't have health insurance.
What about it? More. Keep going, keep going.
By however many numbers.
Well, how many?
1.05.
1.05 million per year. That's what I need to hear. Perfect, sister. Yes, it basically gives you a rate, but now give it, that's why this in context is so important, in context. You're increasing 1.05 million, it's a Y value, 1.05 million more uninsured per year. And if you want to get really saucy, throw an on average on there. On average, 1.05. If you're going saucy, statistically saucy. Because it is an average, right? It's not consistently 1.05 per year. It averages to 1.05 million per year. But you see how I got all those words in there? We got the context of what the Y value is, 1.05 million. We got the per year in there. Now, the per year is hidden on the slope. If you look at the TI, when you run that Lin reg, it gives you the slope as 1.05. It does not write it as a fraction. It does not say over 1. You have to know that. It's that over 1. Whatever that number is, over 1 is the slope of your line. So that's the per year, or per second, or per minute, or per hour, or per unit, or whatever the unit, whatever label the horizontal axis has. Is that believable? I'm big on that. I like harping on interpretations of slope, because otherwise it's just this meaningless number. 1.05, 10.05, whatever. Well, maybe. That's 10 times different. And it's amazing to me, to this day and age, the misunderstanding of scale blows my mind. Blows my mind. I was sitting in a meeting 4 months ago, talking about childcare on campus, how there is none. And how I think there should be. I think there should be. A lot of people do agree with me as well. There's a task force convened to study childcare on campus. And I'm sitting in this meeting, listening to it, getting all excited. And one of the figures that blew my mind was, if we get childcare on campus, drop-in childcare, not like full-day childcare, but something where you could bring a kid and drop them off for 2 hours, go to class, then go get them. And imagine how much at ease a parent would feel being able to do that, right? It's fantastic. I mean, being a parent myself, I'm like, my God, it would be awesome just to not worry about your child for those couple hours. You go to class and actually learn something. And I kept listening, getting more and more excited, and I was told this is going to impact 1,800 students. I'm like, hot damn. That's like 1 in 10 of our student population. There's like 18,000 COCC students if you count it. 1 in 10 would be, like, that's phenomenal. You know, that's phenomenal. So I'm listening, getting excited. They start talking about the cost. I'm like, give me, how much does it cost? Because I got the COCC annual budget in front of me. I know that number, $110 million. I got that back in my mind. It's always $110 million, basically, every year. A large chunk of which is from the general fund, which would then fund this. And they say, oh, that's cost prohibitive. I'm like, tell me how much it is. And they say it's probably going to be around $100,000 a year. And I'm like, but think about it, $100,000 versus $110 million. It's 1/1000th of the annual budget wrapped up in one program. And just the glazed looks. Like, what do you mean? I'm like, I mean take some zeros off. Get excited, that's cheap in the grand scheme of things. And people just don't get that, friends. They don't understand that idea of scale. You've heard the phrase, oh, wait a minute. For the want of a nail, the kingdom was lost. Maybe not. Wait a minute. Save it. There's a phrase about, like, collecting pennies but losing dollars, and I'm going to murder it right now. But that's the idea. You're spending so much time worrying about these little tiny things. Think about it. If we could impact 1,800 students, what's going to happen to their success rates most likely? They're going to go up, most likely on average. Because our funding from the state, is going to be based on successful completion, that means our money coming from the state is going to go up as well, which could then be rediverted to pay for that. I mean, I'm looking at this huge picture, and people can't get past the fact that it's 1 with 5 zeros. most one with 5 zeros. Right?
Well, enrollment could go up because of
Absolutely. It could be. Oh my God, I can drop my kid off at class, that means I can go to class.
Right.
Yeah. So that's why I harp on interpretations of numbers so much. Because only in how to, and this is something you never do in algebra classes. X equals 2. Thank you, I'm done. I'm going home now. 2 what? X equals 2 what? That's what I want to know what the 2 means. That gets lost in America, I think, sometimes, math education. Justine, do you have a question? I'm sorry. You didn't. Okay. Anyway, back to this. Predict the number of uninsured Americans under age 65 in 1995. Now, I said manual and table. We'll look at it both ways. So the first way, this is something you would have done in Math 60, probably Math 65, maybe Math 95. So the idea is you now have a model for, I'm going to slide the camera off to the side a little bit. There we go. You now have a model. Y equals 1.05x plus 33.1. Don't forget what the X's and the Y stands for. X is years since 1990, and Y is number of uninsured in millions. Okay? Now, I want to know, based on the model, how many in 1995 should have been uninsured. Notice that that data point is missing. 5 doesn't have a data value. It should be that guy right there. And how you would have done it back in the day, you would have said, okay, well, that's 1995, which means that X equals 5 in this case. And then you'd run that bad boy through the equation and figure out what Y is. Hopefully this rings a bell. Like, oh yeah, I remember suffering through this back in the day. So you take this guy, you go Y equals 1.05, X is 5, plus the 33.1. And essentially what you're doing is we're looking at Aaron's slope and we're putting it to work. We're saying every year it goes up 1.05, go up 5 years. So that's 1.05 for each of the 5 years. So what's that? Gesundheit, my goodness. 5.25. I think I did that right. Plus 33.1, which is going to be 38.35. Which means
38.35 million people under the age of 65
when? I just said when? In 1995, yes! But Frankie took that for granted. She's like, you already told me it was 1995, thanks. Yes, in 1995, there were about 38 1/3 million people uninsured. And this is the way you would have done a lot of this back in the day. So, and that's fantastic. But once we take our we'll take our 5-minute break right now. And I want to come back and show you a technological way of getting the exact same answer that's much, much quicker, rather than have to go through this algebra each time. So we'll come back and do that after the break, yes? Cool? All right, take 5. I'm going to kill the camera. We'll come back and use the TI to get the same number. Chelsea, what's on your mind over there?
Well,